All right, let's dive right into the fundamentals of O-level maths. We're going to build your essential number toolkit, and we're starting with the absolute basics, the different types of numbers that are really the foundation for everything else you're going to do. You know, does it ever feel like words like integer, prime, or reciprocal are part of some secret language that only mathematicians speak? Well, you are definitely not alone. But the good news is, by the end of this quick explainer, you'll be cracking that code like a pro.
So, think of this like we're setting up your own personal workshop. First thing we're going to do is stock it with the most fundamental tools, the basic types of numbers. These are like the hammers and screwdrivers of math. You're going to be using them all the time. Let's get started.
We're starting right at the beginning, at the foundation. We're talking about whole numbers and the numbers we use for counting. These are the ones you've been using pretty much your whole life, but now we're just giving them their official, proper names.
Okay, tool number 1 in our kit, the integer. This is super simple. An integer is just any whole number. That means no fractions, no decimals, none of that. It can be positive, like 5. It can be negative, like -3, or it can be 0. They're the solid, reliable building blocks.
And right next to that, we have our next tool, the natural number. Now, these are a little more specific. They are just the positive integers, what you probably know as counting numbers, right? When you count things, 1, 2, 3, 4, you're using natural numbers.
So, what is the big difference here? Well, think of it like this. All natural numbers are integers, but not all integers are natural numbers. Integers are the whole family, right? The positives, the negatives, and 0. Natural numbers are just the positive ones, and they start from 1. 0 is not included. That's a key detail to remember.
Okay, so we've got our basic numbers sorted. Let's grab the next set of tools for our toolkit. These are all about how numbers relate to each other. Specifically, we're talking about multiples and factors. And trust me, understanding this relationship is key.
Let's start with a multiple. The easiest way to think about these, they're basically the results from a times table. So a number is a multiple of another if you can divide it perfectly, with nothing left over. For example, 12 is a multiple of 3 because it's in the 3 times table. Simple as that. Now for the other side of that coin, a factor. A factor is a number that divides into another number perfectly. So if 18 is a multiple of 6, then that means 6 is a factor of 18. See, they're like a matched pair. And a really important thing to remember is that any integer bigger than 1 will always have at least 2 factors, 1 and itself.
But how do you find all the factors of a number? Well, here's a foolproof method. You always start with 1 and the number itself. That's your first pair. Then you just work your way up. Does 2 go in? Yep, 2 times 9. How about 3? Yes, 3 times 6. You just keep testing until the numbers start to repeat, and boom, you've got your full list. And here, my friends, are some amazing shortcuts. These divisibility tests are absolute time savers, especially when you can't use a calculator. Want to know if a huge number is divisible by 3? Don't bother dividing, just add up its digits. If that sum is divisible by 3, the whole number is. So useful. All right, basics are down. Now it's time to bring out the specialist equipment, the power tools of your number toolkit. These are numbers that have really unique properties, and they are absolutely crucial for solving certain types of problems.
And kicking us off is the prime number. The definition is simple, but so important. A prime number has exactly 2 factors. No more, no less. Just 1 and the number itself. That's why, by the way, the number 1 is not a prime number. It only has 1 factor.
And here is a fantastic bit of trivia that's also a vital math fact. The number 2 is the only even prime number. Think about it. Why? Because every other even number on the planet is divisible by 2, which means it automatically has more than 2 factors.
Okay, let's put our new tools to the test. Here's a question that could totally pop up on an exam. Is 51 a prime number? Well, it's not even, and it doesn't immediately scream that it has other factors. So, how do we check for sure?
This is exactly where our divisibility tests become our best friend. We already know it's not divisible by 2. But what about 3? Let's use that trick. Add the digits. 5 plus 1 equals 6. And since 6 is divisible by 3, that means 51 is 2. And just like that, we've proved it. It's not prime. Case closed.
Okay, moving on to our next power tools, square and cube numbers. These show up all the time. A square number is just a number multiplied by itself. A cube is a number multiplied by itself and then by itself again. Now here's a real pro tip. Memorizing the first 15 squares and maybe the first 5 cubes will save you a ridiculous amount of time in your exams. Seriously.
We are on the home stretch now. For the final pieces of our toolkit, we're looking at the opposites, kind of like the undo buttons for some of the operations we've just talked about. These are your roots and your reciprocals.
So how do these opposites work? It's really straightforward. Square roots and cube roots are just the reverse of squaring and cubing. If you square 4 and get 16, then the square root of 16 takes you right back to 4. They just undo each other.
And finally, the reciprocal. This sounds way more complicated than it is. It's just 1 divided by the number. So for a whole number like 3, the reciprocal is 1 over 3. And for a fraction, like 2 over 3, you just flip it upside down to get 3 over 2. And the coolest part? Any number multiplied by its reciprocal always equals 1.
And there you have it. In just a few minutes, you've put together a really powerful toolkit. You've got your basic foundational numbers, your specialist power tools like primes and squares, and even the opposites to help you work backwards. You are officially equipped.
So, the only question left is, with this brand new toolkit sitting right in front of you, what problem are you going to go out and solve first? Thanks for tuning in.